Hey, good morning, Mr. H here. Man, we're coming down to the final stretch here. Last week, new stuff, just a couple topics to go. So today we are going to chat probability, which we'll all run into now or then with something in life. So we're going to just do a few basics to start, kind of build up a little bit from here. Lots of stuff that shows up on standardized testing, stuff like that. So it's worth a good look here as we go down the home stretch. So calculating basic probability. Okay, we're going to start with a deck of playing cards. Now, I will have some people out there that have never dealt playing cards before. So we're going to take a couple notes here at the start on what it is, some of the numbers, things like that. So you can know these things. So there's 52 cards total in a deck of cards. Okay. There's 13 of each suit. Now, a suit, which I had to play a deck of cards here with me now, are the shapes that you see on there. So there's hearts, there's diamonds, there's spades, and there's clubs. So there's 13 of each one of those. The other thing we want to keep track of here, okay, is that there's 26 of each color, and there's two colors, red and black. And the last thing I'm going to do, this might be overkill, but I'm going to make sure. When there's 13 of each of the suits, you're like, okay, so what are those 13? Those 13 would be a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, a king, and an ace. Okay, so those are the 13 cards that I have in these 4 different suits. Okay, and I'll make one last note here. Hearts and diamonds are red. Spades and clubs are black. I think I've covered everything at this point if you don't have backgrounds with cards. So as you're jotting that down and trying to wrap your head around that a little bit, and maybe, you never know, if you ask at home, there probably is a deck of cards somewhere around. You could probably get a more physical look at things here. So we're going to have this deck of playing cards, these 52 cards. And we're going to pull one card. So it's like we put all the cards down, spread them out, maybe fanned them out a little bit, and you're just going to go and pick one at random. So when we're doing basic probability, okay, what we're going to have is what's called, I took up all my space with writing there, so watch this move. Okay. What we call our successes over our total when we're doing basic probability. Okay, I'm going to outline this in red so you can kind of see these go together. So what would be my total in each of these? Well, if I'm pulling one card from a deck of cards, it's something out of 52 because there's 52 total cards that I could possibly draw. Okay, so probability of getting red. Now, it's not 1 out of 52. How many red cards are there? There's 26 of them. So 26 out of 52. If we can reduce, we know this, we've known this since we started dealing with fractions way back when. If we can reduce, and we can, oh, my head's in the way, okay, is 1/2. We would need to get all the way to that simplified form, okay? And so probability of a heart. So I look, well, there's 13 hearts, so 13 out of 52. And again, if I need the help, is 1/4 because they're each divisible. Now, if you think about that for a minute, doesn't that make sense? 26, half the cards are red. Oh, 1/4 because there's 4 different suits and there's the same amount of each. So sometimes I can kind of think ahead a little bit here to see. Now, I got to start thinking a little more carefully here. Probability of getting a red 7, okay? So each card that I have up here, I have 4 of them. I have a heart, a diamond, a spade, and a club of each of those. So to get a red 7 would be the 7 of hearts, because hearts are red. And the 7 of diamonds, because diamonds are red. So 2 out of 52. Or if I do my math, enter, just realize they're both divisible by 2. I get 1 over 26. And then I get to the last one. I'm trying to mess with you here. A black heart. We already wrote hearts are red. I can't get a black heart. Probability is 0. You can't get a black heart unless somebody's messing with you and has changed the deck around, because a normal deck wouldn't have that. That's the process we're working through here, okay? Rolling a 6-sided number cube. Why they call this that and they don't just call it a 6-sided die, I don't know, but we'll roll with it. So again, we're thinking success out of total. So if I look at that and I go, okay, so if I'm rolling a die, there's 6 sides. Unless we're dealing with one of those funny 20-sided cubes or something else, they go, but here it says 6-sided. Okay, what's my success? What's my chance of getting a 4? Well, on a 6-sided cube, I can get 1, 2, 3, 4, 5, or 6. Am I saying you need to write out every single possibility every time? If you have background with it, maybe not. If you don't, maybe. So possibility of getting a 4. Now I see 1 4 there, 1 out of 6. Probability of getting an even number. 2, 4, 6 would be 3 out of 6, but reduce if you can. 1/2. The probability of getting a number greater than 1. Okay? If it's pointing at 1, it'd be greater. If it was being eaten by the 1, it'd be less than. So a number greater than 1. 2 is greater, and 3, and 4, and 5, and 6. 5 out of 6. And finally, another one of our favorites, the probability of getting the number 7. Already, there's no 7 there. You're right. No chance. Okay? So now, that's more of our basic probability. Okay? The simplest of simple. We're going to go a little beyond that. Okay? So we got Bill, John, Sue, and Bob are all up for a promotion. Their boss is going to choose a team of 2 people to lead the department. Everyone is equally likely to get the position. Show the possible combinations for the team. Show. We're going to draw a little bit of a chart here. And here's what I like to do. I like to look at this and I go, okay, so I'm just going to go in order here. So if I start with Bill, Bill could get comboed with John, could get comboed with Sue, could get comboed with Bob. Okay? So let's say now instead of starting with Bill, we start with John. We're just going to work in order here. Now, if I start with John, be careful. I can't combine him with Bill. Why not? Because it's not saying like one's going to be a president and one's going to be a vice president. It just says it's a team of 2 people. Bill and John and Bill, it's the same combo. So here, I want to see if I have unique combinations. So John and Sue, that's not a combo over here. John and Bob, that's a combination that's not over here. But John and Bill would be. Okay, so I'm not going to do a repeat here. Or maybe you can go through and if you put it in, you could cross it out. I don't know. Then we start with Sue. Like, okay, so Sue, can I start with Bill? No, because I got Sue and Bill here. What about John? I got Sue and John here. What about Bob? What about him? Okay, Sue and Bob we could do. And then if we got to Bob, Bob's already comboed with everybody. Bob's comboed with Sue, Bob's comboed with John, Bob's comboed with Bill. So we don't have any more. So how many options do I have? 1, 2, 3, 4, 5. 6 total combos. Okay? So over 6 would be my number here. And now I look through. Bill and Sue get the promotion. Well, there's only one way I can get Bill and Sue. 1 out of 6. Okay. Bob is one of the people getting the promotion. So what that means is every combination that has Bob included, 1, 2, 3 of them, would be my value here. And again, if I can reduce, I should. Success over total when we're talking about basic probability. Okay? Now, a couple more rules that can go in with this as we continue to grow a little bit with this. So don't freak out at the language down here. I know some of it's weird. Mathematicians are weird with this stuff, but I'll just kind of explain what I mean. The probability of an event A happening is denoted by P sub A. You're like, okay, so what does that mean? If you look back up here for a minute, okay, notice how it said P sub 4. What's the probability of me getting 4? What's the probability of me getting even? This is just the probability of whatever event you are checking on. What's the probability of Bill and Sue getting the promotion? We're just explaining to people in there what we're looking for the probability of, whether it's a number, a phrase, whatever it is. The probability of any event is a number between 0 and 1. The closer to 1 the probability is, the more likely the event is. 0 represents a 0% chance. We saw a couple of those up above. 1 would represent a 100% chance. And so every decimal in the middle would represent that percentage. So like if I said the probability of something happening was 89%, that would be represented as 0.89, okay? Because again, it's always going to be somewhere in between 0 and 1 when we're talking about probability. The sum of the probabilities of an outcome in a sample space is 1. You're like, okay, what does that mean? Okay, so here's an example of what that would mean. I'm going to go back to my die here for a minute, my 6-sided cube. So if I think about the 6 options that I have when I'm rolling a die, and we talked about this up above, there's a chance on each one, there's a 1 out of 6 chance that I get each number. So what is this saying? The sum of the probabilities of a sample space is 1. If I add up 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, I get 6 out of 6 or 1. If I look at every single possible outcome and I add all of them up, I'm going to get to 1. Okay, and that's true if no matter what you do. You can do it with Bill, John, Sue, and Bob. You can do it with a die. You can do it with a deck of playing cards. Man, I wouldn't want to write it out with a deck of playing cards, so that's a lot. But that's what we're looking at here. And then the final one here is the probability of an event not occurring, not happening, is the same as 1 minus the event of it, probability of it actually occurring, okay, which is known as a complement. So our last example here says if the probability of an event occurring is 3 out of 5, that it's going to happen is 3 out of 5, what's the probability that it doesn't? 1 minus 3 out of 5. I can put that in my calculator, but let's just think about it in a minute. If I had a common denominator, that'd be 5 out of 5. And if you really think about it for a second, couldn't we figure that out pretty easily? It's like, if event occurring is 3 successes out of 5, how many instances are there left that wouldn't work? 2, because 3 plus 2 is 5, and it has to add up to 1, right? That's the way we think as far as probability goes. So as we take a flip over, sometimes we are going to find that multiple events are going to go on. It's not just one event that happens, like, flipping a coin or rolling a die. Sometimes we may do all these things together. So independent events are what we call multiple events that do not affect each other. So for example, with our first example here, if I roll a dice and flip a coin, what I get on the dice is going to make no difference than if I flip heads or tails. Or if I flip heads or tails, it's not going to make me get a 3. They're independent of each other. So let's read this out. What's the probability you will roll a 5? Okay, think about a dice. There's 6 sides. One of them has a 5. Then we're going to multiply. Flip a tail. Well, when I flip a coin, there's only 2 options, heads or tails. And there's only 1 tail on there. So basically, they're just saying take the 2 events, take their probabilities, multiply them together. 1 out of 12 would be my probability. Okay. If you roll a pair of dice, 2 dice, what's the probability you'll roll a pair of 3s? Okay, each one is separate. The first time I roll a die, there's 1 3 out of 6. The second time I roll, again, totally independent. What happened on the first die has nothing to do with what happens on the second one. There's also a chance of 1 out of 6 of that happening. So the probability of you getting a pair of 3s would be 1/6 times 1/6, or 1/36. And we go with that. Now we'll crank it up a little bit. The chance of you passing a test A is 40%. Ooh, that's a toughie. The chance of you passing test B is 20%. Holy cow, either we didn't study or this teacher is woofda. Note that the tests are independent of each other. So maybe we call it a math test and a science test or something. I don't know. Okay. Probability that we fail A and fail B. Now, here's a suggestion for you on something like this. Notice both the ones I have. Passing test A is 40%. Okay, if my chance of passing test A is 40%, what's my chance of failing test A? 60. How do you figure that out? Well, 100% of the time, you're going to pass or you're going to fail, right? So if 40% is pass, 100 minus 40 would be 60% that I'm going to fail test A. I would write that out and have it in front of me. The chance of you passing test B is 20%. Same question. If 20% passes, what percent fails out of 100? 80% fails B. Now I have every option. The only options you have on a test is pass or fail. Adds up to 100, adds up to 100. Okay, now I'm ready to go. Probability of failing A, okay, when we do these, we do them, use percentages as decimals. Okay, because remember, probability has to end up between 0 and 1. So let me explain that as we put this in. So fail A would be 0.60. Fail B would be 0.80. I multiply those together. Okay, 0.48, 0.48 or 48%. Because remember, the value we get is supposed to end up between 0 and 1. If I did 60 times 80, that's 4,800. That's a lot bigger than 1. So we don't want that. So make sure you're using decimals. And this would be the way your answer would be written most of the time. It may, if you're written as percent, we change it a little bit. And that's all we're going to do. Pass A, 40%. Fail B, 80%. Multiply the two decimals together. 0.32. And just keep rolling. Fail A, pass B, so just be careful. We've been having all the fail B's here. 0.12. And finally, pass A, 40%. Pass B, 20%. 0.08. If you're doing this in your head especially, watch for the places where the decimal point goes, because 0.8 would be 80%. That's a lot. Note, this is every possibility. Fail, fail, pass, pass, fail, pass, pass, fail. That's the only 4 options there are. But if you add those numbers up, if you add up those 4 values, what do you get? 1, because that's the entire sample space. Okay. Now, one last thing. Okay, those were independent events. One thing happens, it has no bearing on the other thing happening. Well, what happens if we get into some situations where the events do affect each other? Okay, so we're going to go back to our deck of cards. So if you need to flip back and forth here, we can do that. If you have a deck of cards, what's the probability that you will pull 2 aces in a row? This is called without replacement. So I have my 52 cards laid out, okay? And I'm going to randomly draw 2 of them, hoping to get 2 aces. So here's what we're basically doing. We're saying the probability of drawing an ace times the probability of drawing an ace. So we know how probability works now. We know there's 52 cards in a deck. Okay. How many aces are there? Well, maybe we need to go look at that for a minute. Okay. So there's 4 different colors, 4 different suits for each one of these. So there's an ace of hearts, an ace of diamonds, an ace of spades, and an ace of clubs. So there's 4 of them. We should add that on the other side too. Over here, 4 of each of these, because there's 1 of each suit. Okay, so we got 4 aces. So we come back over here. 4 out of 52. Can I reduce it? Punch in the calculator, hit math, enter. 1 out of 13. Now, here's where without replacement comes in. We got to visualize this. Take a deck of cards. I pulled an ace. Woo! I got my ace of hearts, let's say. Now, here's the question. We're not putting this back in the deck, back into our pile. If I take this one, how many cards are left in my pile? It's not 52. Now there's only 51. So I have to pay attention on if something's being put back in or not. Now, how many aces are left in the pile? We know there were 4, but I have 1 of them in my hand. So now there's only 3. Again, put that in your calculator, hit math, enter. Let's stay simplified here. So 1/13 times 1/17, man, that's not very good chances. What this tells me is, if I were to do an experiment, okay, technically I should only get 2 aces in a row if I was just randomly pulling 1 out of every 221 times I tried this. Gracious. I don't think I'd be able to stay that patient to try it that many times. Now, does that mean for sure you would only get it once every 221 times? No, you can get it 2 times in a row. I mean, this is just telling you what things technically should be or should work out with this. Okay? So, okay. Practice, because we need practice. And yes, this is showing up on the final, so don't blow this off. Okay? So practice with basic probability. Okay? We talked about independent versus dependent events. Okay? 2 things that happen don't affect each other at all. 2 things that happen that do affect each other. So one of my favorite examples, let's say, of 2 dependent events would be Halloween. Halloween, you go out and you get a bunch of candy in your bag or whatever, okay? If you counted each type of candy that you got and then randomly stuck your hand in, you're like, woo, I got a Snickers. Okay, what's the probability I'm going to go get another Snickers? Well, it depends, okay? Because I already took 1. It's sort of like our last example with the cards. But again, we look through these. Okay, I'm going to actually do one of these. In the school library, there's 7 algebra books, 8 geometry, and 5 stats books. So Carlos selects 2 books at random with replacement, find the probability. First thing, how many books are there? 20. Okay. How many of them are algebra? 7. You're like, okay. Now, here's where you've got to be careful. With replacement, which means when Carlos picks that algebra book, okay, off the shelf, before he tries to pick the next book, he's putting it back on the shelf. He probably saw his algebra and decided he was going to put it back on the shelf, right? Bad joke. So we're still going to have 20 options and multiply these together, okay? So again, you've got to pay attention to words. Because when you get to the next section and it says without replacement, life changes. We have 15 pencils. Okay, that's our total. 9 of erasers, 6 do not. So probability of getting one with an eraser. 9 have erasers. Okay. But now I took the pencil out of the drawer. Corey took this pencil out of the drawer, didn't put it back. So how many pencils are left in the drawer? 14. Okay, now I'm drawing out of those 14 and trying to find one that does not. There's 6 of them. Reduce your fractions, multiply through. That's the type of thing I want you thinking about here. Those are the details, especially with these type, where we've got to read carefully to see what the situation is. Okay, we're almost there. 1 lesson to go, people. You've almost survived Algebra 2. Good job. If you have questions, let me know. Otherwise, we'll see you next time.